Here we have the problem from complex numbers for IPE. So what is the problem here? If Z1 is equal to minus 1, Z2 is equal to minus I, then find argument of Z1, 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 Z2. Second one, Z1 is equal to minus 1, Z2 is equal to I. Then find the argument of Z1 by Z2. So first one. Okay, here what given here? Z1 is equal to minus 1, Z2 is equal to minus I. We have to find argument of Z1, Z2. Okay, all of you. Suppose A plus IB is the complex number, then this is, you take here Z is equal to A plus IB. Then argument of Z is equal to theta is equal to tan inverse of B by A is the argument of Z. Okay, all of you. Here first one, Z1 is equal to what? Here 0 minus 1 plus 0 into I. What is Z2? Z2 is equal to 0 minus I. So Z1, Z2 is equal to what? Minus 1 into minus I equal to I is equal to 0 plus I. Here A is equal to what? In this, A is equal to 0 and B is equal to 1. Then argument of Z1, Z2 is equal to what is here? B by A. Tan inverse B by A 1 by 0 is equal to tan inverse of pi by 2. This is tan inverse of infinity is equal to pi by 2, this value. Okay, all of you. Argument of Z1, Z2 is equal to what? Pi by 2. We have to find argument of Z1, Z2 is equal to pi by 2 is the answer. Okay, all of you. That's all. You see, all of you, second problem. Here, this is the second problem. Z1 is equal to second problem. Z1 is equal to minus 1. Z2 is equal to I. Then find argument of Z1 by Z2. Here Z1 by Z2 is equal to, this is minus 1 by I. You can multiply and divide with I. Okay, all of you. Then what is minus I by here I square? We know that I is equal to root minus 1. I square is equal to minus 1. I cube is equal to minus I. And I power 4 is equal to 1. This is the formula. Iota is equal to. Here, what is iota square? Iota square is equal to minus 1. So, Z1 by Z2 is equal to minus I by minus 1. So, minus minus get plus. This is the only iota. So, Z1 by Z2 is equal to 0 plus I. In this, A is equal to 0 and B is equal to 1. Then what is argument of Z1 by Z2 is equal to theta is equal to tan inverse of 1 by 0. This is tan inverse of infinity is equal to pi by 2. Tan pi by 2 is equal to infinity. Tan inverse of infinity is equal to pi by 2. Okay, all of you, that's all. Here one more problem from complex numbers for IPE. If z is equal to cos theta sin theta, find z minus 1 by z. Okay, all of you. Here what is z? Z is equal to cos theta comma sin theta is equal to cos theta plus I sin theta. Okay, all of you. So 1 by z is equal to what? 1 by z is equal to 1 by cos theta plus I sin theta. You can convert into denominator as real number. That's why you can multiply with cos theta minus I sin theta and divide with cos theta minus I sin theta. Implies 1 by z is equal to cos theta minus I sin theta by this is a plus b into a minus b. So cos square theta minus I sin theta whole square. We know that a plus b into a minus b is equal to a square minus b square. So 1 by z is equal to cos theta minus I sin theta by this is cos square theta minus I square. I square value is minus 1, minus into minus plus. This is sin square theta. We know that cos square theta plus sin square theta is equal to 1. So by using this trigonometric identity is equal to what? Cos theta minus I sin theta. 1 by z is equal to cos theta minus I sin theta. Z is equal to cos theta plus I sin theta. So z minus 1 by z is equal to cos theta plus I sin theta plus cos theta minus I sin theta. This one minus I sin theta plus I sin theta cancel is equal to 2 cos theta. Cos theta plus cos theta is 2 cos theta. Z minus 1 by z is equal to 2 cos theta. Answer. Okay, all of you? That's all. Here we have one more problem. Find the additive inverse of minus 6 comma 5 plus 10 comma minus 4. So what is given here? Additive inverse of, we have to find additive inverse of minus 6 comma 5 plus 10 comma minus 4. Here minus 6 comma 5 plus 10 comma minus 4 equal to minus 6 plus 10 comma 5 minus 4 is equal to, this is 4 comma 1. So 4 comma 1 is equal to 4 plus I. Additive inverse of z is equal to x plus iy is minus z is equal to minus x minus iy minus z is equal to minus x comma minus y. By using this formula here, 4 plus I additive inverse is equal to minus 4 minus I equal to minus 4 comma minus 1 is the additive inverse of the given problem. Okay, all of you, that's all. Here we have one more problem. Find the real and imaginary parts of complex number a plus ib by a minus ib. So here you see given a plus ib by a minus ib. You can multiply and divide with a plus ib by a plus ib. So this is a plus ib whole square by this is a plus b into a minus b form. A square minus ib whole square is equal to, this is a square plus I square b square plus 2i ab by here a square minus I square b square. We know that iota is equal to root minus 1, iota square is equal to minus 1, iota cube is equal to minus I, iota power 4 is equal to 1. So here iota square is equal to minus 1. So what is a square minus, this is minus 1 into b square, minus b square plus 2i ab by denominator, this is I square minus 1 into minus plus. So a square plus b square. So this can be written as a square minus b square by a square plus b square plus I into 2ab by a square plus b square. Okay, all of you. What is the real part? This is the real part of the given complex number. This is the imaginary parts of the given complex number. Then real part, real part is equal to a square minus b square by a square plus b square, and imaginary part is equal to 2ab by a square plus b square. Okay, all of you. That's all. Real part of the given imaginary complex number, imaginary part of the given complex number. That's okay. Here one more problem from complex numbers for IPE. Find the multiplicative inverse of 7 plus 24i. Let you take z is equal to given 7 plus 24i. So here if z is equal to x plus iy, then what is multiplicative inverse? Multiplicative inverse. Multiplicative inverse of z is 1 by z. So 1 by z is equal to 1 by x plus iy, x minus iy by x plus iy is equal to x minus iy by x square. This is x minus iy, x square plus y square is the multiplicative inverse of z is equal to x plus iy. So here z is equal to 7 plus 24i. Then what is multiplicative inverse? Multiplicative inverse mi is equal to 1 by z is equal to 1 by 7 plus 24i into 7 minus 24i by 7 minus 24i. Okay, all of you. So 1 by z is equal to here 7 minus 24i numerator, denominator a plus b into a minus b. 7 square minus 24i whole square is equal to 7 minus 24i by here 7 square is 49 plus I square value is what? Minus 1. Minus into minus plus 24 whole square. 24 whole square is 6 24 24 4 4 the 16, 4 2 the 8 plus 1 9. This is 8 4. This is 6 7 576. 576 is equal to 7 minus 24 by 24i by 576 plus 49 625. Okay, all of you. What is the multiplication of multiplicative inverse of z is equal to 7 plus 24i? This is 7 minus 24i by 625 is the multiplicative inverse of given z is equal to 7 plus 24i. Okay, all of you. That's all. Here we have one more problem from complex numbers for IP. If z not equal to 0, find arg z plus arg z bar. Okay, all of you. Arg z plus arg z bar. You see here, let z is equal to x plus iy. What is arg z? Arg z is equal to theta is equal to, this is tan inverse of y by x. Then z bar is equal to what? X minus iy. We know that. So r z bar is equal to what? Theta is equal to tan inverse of minus y by x. So theta is equal to minus tan inverse y by x. Then minus theta is equal to tan inverse of y by x. This is the argument of z bar is equal to. This is first one. This is second one. What we have to find? Arg z plus arg z bar. So arg z plus arg z bar is equal to theta minus theta is equal to, this is minus, so this is tan inverse of y by x minus tan inverse of y by x. This one cancel, equal to 0. Equal to 0. This is equal to minus theta. Is equal to minus theta. This value is 0. Okay, all of you. That's all. Argument of z plus argument of z bar is equal to 0. Here we have one more problem from complex number. If 1 minus I into 2 minus I into 3 minus I and so on n minus I equal to x plus iy, then prove that 2 into 5 into 10 into so on 1 plus n square is equal to x square plus y square. So here given, what given here, 1 minus I into 2 minus I into 3 minus I and so on n minus I equal to what, x minus iy, equation 1. Similarly 1 plus I, similarly 1 plus I, 2 plus I, 3 plus I and so on n plus I equal to what, x plus iy, equation 2. So 1 into 2 you can do. 1 plus I into 1, 1 minus I into 1 plus I. 1 minus I into 1 plus I. Okay, all of you? 2 minus I into 2 plus I. Okay, all of you? 3 minus I into 3 plus I. And so on. N minus I into n plus I equal to x minus iy into x plus iy. So this is implies, what is the value? 1 square minus I square, 1 square minus I square, 2 square minus I square. Here 3 square minus I square. Here and so on. N square minus I square is equal to x square minus I square y square. But what is I square value? I square is equal to minus 1. Iota square is equal to minus 1. So 1 square minus 1 into minus 1 minus into minus plus. 1 plus 1 2. 2 square 4 plus 1 5. 3 square 9 plus 1 10 and so on. Here n square plus 1 1 plus n square is equal to, this is x square plus y square. So hence proved. Hence proved. Okay, all of you. That's all. Thank you.